no pull-up resistor, and no pull-down resistor. So this is input floating mode. Hello, welcome back. Before we use GPIO to light the LED, we first need to know what is GPIO is. So what is GPIO? This is a brief introduction here. There are 8 input or output modes. For output mode, the MCU sends high level or low level signal to external device. 3.3 volts generally or 5 volts for high level and 0 volts for low level. We often use output mode to light the LED, control buzzer, and simulate communication timing. For input mode, the MCU read level signal including high or low from external devices. I give you an example. When you push a button to light a LED, the pin of MCU will receive a high level is 3.3 volts, and the MCU will control the LED on. This is the 8 GPIO mode. Let me check it. The first 3 are all input mode, so this pin can read pin level. And the difference is, if the pin is not floating, the level is uncertain for input floating, and when pin is not floating, is default to high level for input pull-up because there is a pull-up resistor connected to internal. And when not floating, is default to low level for input pull-down because there is a pull-down resistor connected to internal. So in order to let you understand it more easier, let me check the reference sheet. Okay, this is the reference sheet now. Let me find the GPIO. This one, click. And these are 8 GPIO output or input mode here. And this is the basic structure of standard I/O. You can see that there are 2 parts here, input driver and output driver. If you only see the input driver, we can ignore the output driver, right? So we can check this picture. This is the input configuration, and the part of output driver is closed. So we can only see the input driver. The direction is like this for input mode. This is I/O pin, and this 2 diode is used to limit the current to protect our MCU. There are 2 switches here. We can configure this 2 switch to set as input floating model or input pull-up model or input pull-down model. So let me check it. If we only close the upper switch, there are pull-up resistor here, right? We configure this pin as input pull-up mode. And if we close the below switch, there is a pull-down resistor here, right? So we configure this pin as input pull-down mode. If the both of 2 switches are all open, it means no pull-up resistor and no pull-down resistor, right? So this is input floating mode. If the pin are floating, the level is uncertain, right? Maybe you kind of confused about the Schmidt trigger here. I give you explanation. This picture is characteristic curve of Schmidt trigger. Maybe you also get a little bit confusion here, but the conclusion from this diagram is only if the input voltage for Schmidt trigger higher than a certain level, the output is high. In same way, only if the input voltage lower than a certain level, the output is low. I give you an example. Sometimes the high level appears at I/O pin. It's not this. Maybe it's like this. Some oscillation here. So the Schmidt trigger is used to filter this oscillation. And let me go on. Analog, the GPIO is invalid. The pins are directly connected to the internal ADC. We also can check it on datasheet. For this picture here, the path of read analog signal is like this, right? Don't pass this Schmidt trigger. Just now I said the Schmidt trigger can only output the high level or low level voltage, right? And the MCU can only read the 1 and 0 for input mode. But for analog input, it's not past Schmidt trigger. If the input voltage is only 1.5 volts, the analog can also read this volt and convert it to the analog value. And these are 2 output modes, output open drain and output push-pull. The same is they are all output pin. The difference is a high level is a high impedance state for output drain. And for output push-pull mode, a high level connected to the VDD. This is different. And the same is a low level are all connected to VSS. Let me check on the reference sheet. We can check this diagram, the picture of output configuration. We don't need to see the input driver. The output direction is like this. You can write a code about the bit set or reset register and output data register to configure which pin is used to output mode and output high or low. And you can notice that there are two modes here, PMOS or NMOS. If we use these two modes, the output pin is connected to VDD and also connected to VSS. So we connected this pin as the output push-pull mode. And if we don't use this pin mode, it means a high level is high impedance state. So we configure this pin as the output open drain. And the last two is alternate function push-pull and alternate function open drain. And the different from the upper two, output open drain mode and output push-pull mode. These two pins are controlled by on-chip peripherals. We can see this picture. Generally, we use this path to control the output pin. And we also can use this path. It means we use on-chip peripherals like I2C or UART to control this output pin. And we also configure this output pin as open drain mode or push-pull mode. Okay, this is the 8 GPIO mode. I think you can easy to understand what is this after listening my introduction. And this is the basic structure of GPIO. This is our GPIO here, GPIO-A and GPIO-B. You can see that both GPIO-A and GPIO-B are belong to APB2 bus. The full name of APB2 is Advanced Peripheral Bus 2. So if you want to use GPIO-A or GPIO-B or C, you need to open the APB2 bus first. This is the key point when you writing code. I will use GPIO to light the LED. Thank you for your watching.